Hi, my name is Luke, and this is the robotic cat laser toy for our final project in CSIS 2810. My teammates are Michael and Eric. So our goal was to create an automated laser toy that would entertain cats by a moving laser pointer in random patterns. To achieve this, we combined embedded system design with mechanical components, all controlled via microcontroller. For this design, we used the key components, the Arduino microcontroller, running code to control the hardware, servo motors to provide vertical and horizontal motion, the laser pointer, and the bracket mounting parts to secure this assembly together.
Hello everyone, my name is Mike McCleary. I'm going to be demoing the physical build of our project. So as you can see here, we have our Arduino R3. This is the cable that will be plugged into our power source, in this case, laptop. We have all our necessary wires, our grounds, our positive charges for voltage. Everything's connected through wires that either connect together, or we had to use crimping tools to extend the life of wires that didn't have connectors on them. And if I scroll in here, you'll notice we have two motors, each one with a piece on top that was mounted. So on the bottom motor, servo, we put another servo motor, and on top of the second servo motor, we put a laser. Now, what this build gives us the ability to do is rotate horizontally and vertically to change the trajectory of our laser that can be followed by any cat or pet. And what we do now is when it's under power, you'll notice that each of the servo motors both move in a random order based on the code that we'll be showing. And if I turn off the lights and we put the laser towards this wall, we'll simulate the movement that would be used where a cat or any other pet could follow. Here is the code for our laser cat toy project for CSIS 218 for fall 2024. So starting at the top, we have included our library for our servo.h library, which gives us the ability to program the movement of a servo motor or multiple servo motors. So we've set up a vertical and a horizontal servo motor. Our vertical is attached to lead 8 on our Arduino board, horizontal is attached to lead 9. Our migrate function essentially reads the current position of the servo and then moves it to the new position. We increased the degrees of movement to 2 per movement in order to increase the speed of our laser moving across the surface. We have a random position function as well. So one for the horizontal movement, we created a range of motion in degrees from 40 to 120. Same thing for the vertical range. We have from 90 degrees to 135. This helps give us on both axes the ability to migrate the servo motors. And then essentially our main program, or our loop, essentially runs random position, again, for horizontal and vertical, which then moves the servo motors. And then we have this delay step as well. Once the laser reaches its targeted random position, we can set the delay. We set our delay at ½ a second. This can be increased or decreased depending on the owner's preferences, but for our purposes, this is our code that we felt was the ideal way to program our physical build. in order to demo what we wanted to solution for our proposed problem.
So now that you've seen the system in action, here's some uh, lessons that we learned throughout this project. The first being we applied MIPS language for theoretical exercise and wrote the actual implementation of C++ to program the Arduino. We synchronized control commands with the physical motion of hardware. This taught us how to integrate precise timing and signal execution. Um, this project deepened our understanding of how software and hardware work together to create functional devices. We also explored how general purpose input-output pins communicate with servo motors and how PWM signals adjust the motor angles. And finally, by programming the Arduino, we gained hands-on experience configuring GPIO pins, understanding memory mapping, and optimizing low-level instruction. So, yeah, this project helped us bridge the gap between theoretical knowledge and practical application, preparing us for more advanced embedded systems challenges. Thank you.